thanks for joining me again. I'm still here and I'm finally going to talk about science. I'm particularly excited this week because I'm finally starting my series called PhysicsBits, where I will pick different chemistry concepts and ideas and talk about them in a more casual sit-down video kind of style. The first video on this series will be on what is the greenhouse effect and why is it important to understand. First of all, I wanted to choose the greenhouse effect because if it wasn't for the greenhouse gases and the greenhouse effect themselves, life as we know it starting 6 million years ago might have not been the same, or we would still be in an ice age. Not fun. I want people to understand what these are so we can focus on the real issue here, which is the rate at which these gases are increasing and how that works with the greenhouse effect, leading us to global climate change. So let's get started. Okay, so I have some notes on my computer that I will be kind of looking at throughout the video in case you see me glancing somewhere else. But let's take a step back for now, and for that we need to understand what an atmosphere is. An atmosphere can be defined as an envelope of gases surrounding a planet, in our case the Earth. Our atmosphere is made up of 78% nitrogen gas, 21% oxygen gas, 1% argon, and all the other small fractions are mostly greenhouse gases. Let's put a pin on that, and for a second let's create a visual here. Here I have my Earth, and here I have my Sun, which is a star and is in a constant burning fuel process, so it's shooting energy in the form of light onto us. The Earth's surface is 71% water, so 30% of that light will be reflected back into space. Water is only able to absorb longer wavelengths of light, which are red, yellow, and green. The smaller wavelengths are going to be reflected back into space, which are the infrared wavelengths. Now here is where the atmosphere comes in handy. We have a gas protection. However, because of nitrogen and oxygen gas molecule structure, a lot of that infrared light and the way it interacts, which is heat energy, merely goes through them and is lost into space. So we have two nitrogen atoms, which is nitrogen gas, and a lot of that infrared light, if you see here my two nitrogens, and here's the bond between them, a lot of that infrared light would merely just like go through it. So if it wasn't for the greenhouse gases and we only had nitrogen and oxygen gas as our atmosphere, the actual temperature on Earth would be around -18 degrees Celsius. Can you imagine that? That's the whole reason we have an ice age to begin with. The levels of CO2 during the ice age were around 118 parts per million. Today we have around 400 parts per million, and it's still growing, and that's no good. And now you'll understand why, because I was talking to someone else and they're like, 100 to 400, that doesn't really seem like a big jump. And I'm like, well, you'll see why. So how did we get here? Why are we like so hot, and why are the polar bears dying? Let me show you. So here's my mock carbon dioxide molecule. Because of its molecular geometry, bond length, and polarity, which is something I will not go in depth in this video, the way it interacts with the infrared wavelength, it's by bending. And during that bending, a lot of the light in the form of heat gets trapped into our atmosphere, hence increasing the temperature here on Earth, which has resulted in a lot of organic organisms being able to live, reproduce, and evolve in the modern day life, which is amazing. So I'm gonna do my model here. Here's my carbon dioxide molecule. Here's the light being reflected from water. And then instead of just going up and going through, it does this and it bends. A lot of that heat is still lost, but a lot of that heat stays here within us. But as the number of CO2 molecules that we have more of that bending and an increase in the temperature we have kept into our atmosphere. So, greenhouse gases are not the devil's work though. They have actually helped shape our civilization in many ways, until we decided to produce them in massive and unnatural amounts that our planet has not been able to keep up with. I will go more into the greenhouse gases themselves in weeks to come, to create a bigger picture on global climate change and the way we impact Earth as consumers and through our daily lives. Hopefully now though, you can understand how increased rates of CO2 and other gases play a role in our current situation. Thank you for watching, and I will see you again next week. Bye-bye. Global climate change, and well, how did we get to problems like the polar bears are dying? I don't want any polar bears to die. So, oh my god, and I'm still here, and I'm finally gonna talk about science. This week in particular, I'm super